Okay, so good day everyone. We are now bound to discuss another topic which is about the wind turbine. So yari na tayo sa photovoltaic and ngayon naman i-discuss naman natin yung another pinagkukuhanan ng energy which is yun nga yung wind turbine. So as you can see naka-off yung camera because of the low internet connection. So next. Okay. So as you can see, this is the visual representation of the wind turbine. Alam ko rin na familiar din ang lahat sa wind turbine. So we are going to discuss how it operates, ano yung mga parts nito, and as well as yung importance.
Wind turbine operating principle. Wind turbine is a type of renewable energy that harnesses the power of wind to produce electricity. The basic idea is that wind turbines uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator, which results in generation of electricity. A large number of wind turbine is usually called wind farm.
Okay, so ano nga ba ang operating principle ng isang wind turbine? So na-discuss natin yung operating principle ng solar energy. So ito namang wind turbine daw is sinasabi dito na gumagamit to ng mga rotor or may mga blades dito na tinatawag. And nasabi rin dito na isa siyang type ng renewable energy. So ibig sabihin nun, hindi kailangan na gumastos ng sobra para makapag-produce ng electricity kasi ito ay isang natural na pinagkukuhanan lang ng power. Okay. So sinasabi rin dito na kapag daw nagtayo ng isang wind turbine or yung malawakan na pagtatayo or yung maramihan, ang tawag na doon is yung wind farm. Next. Okay. So as you can see, these are the parts and operating principle of the wind turbine. So mapapansin natin dito yung iba-ibang klaseng gamit or equipments na ginagamit para makabuo ng isang wind turbine. So meron ditong blades, yung rotor, and as well as yung gearbox. So I just want to emphasize the important parts ng isang wind turbine. So isa raw dito yung gearbox. Ito yung nakatabi sa isang nozzle or yung tinatawag natin na generator. So yung gearbox na yan yung nagpapabilis ng ikot ng blades natin or yung sa main shaft. Yung pinakaikot ng blades na yan is tumatakbo daw siya or umiikot siya ng 12 to 25 revolution per minute. So, sinasabi dito na importante yung isang gearbox kasi hindi siya iikot ng maayos yung isang wind turbine kapag hindi naka-locate ng maayos or naka-proper na naka-properly nalagay yung isang gearbox. Okay, next.
Parts and function. A blade. The blade is the part that relates due to the force it catches from the wind. It is connected to the low-speed shaft via the hub. The low-speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of generator, thereby generating electricity. Most wind turbine consist of 3 blades for maximum efficiency.
Okay. So the first one na parts ng isang turbine is yung blade. Ito yung pinaka-importante or isa sa mga pinaka-importante kasi paano nga naman makakapag-generate or paano makakakuha ng isang yung wind na yon, paano makakapag-generate ng electricity kung wala namang ginagamit para para makakuha ng wind. So sabi rito na most wind turbine consists of 3 blades for maximum efficiency. So makikita natin sa ibang slides dyan na merong mga parts or ibang lugar na gumagamit lang ng isang blade. But then, sinabi na agad dito na 3 blades for maximum efficiency. So, suggested talaga na 3 blades yung gagamitin kapag magpapatayo or gagawa ng isang wind turbine. Next.
Blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbines which are more compact, quieter, and generates more power from less wind. Its length at around 50 meters, which is 107 meter. Currently the longest from Siemens Gamesa.
Okay. So kung titingnan niyo sa picture, parang hindi siya ganun kalaki tingnan sa yung mga wind turbine. Pero sabi doon sa isang statement ni Marcos na nahirapan daw silang i-build yung wind turbine kasi nga sobrang laki. Hindi siya agad-agad ganun kadaling itayo. So kailangan ng sobrang daming manpower. So sa blade design niya, binanggit dito na large and tall. So, kasasabi ko lang kanina na hindi siya ganon kadaling i-build. Okay, so sabi rin dito na yung haba daw niyan is 50 meters. So, ang makikita rito na isa daw sa pinakamahabang nakapag-build ng wind turbine is dito sa may Gamesa. Okay, next.
Blade design. Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies.
Okay, so etong airfoils naman is it allows nga na makapag-rotate ng mas maayos or mas mabilis yung blade natin para makasabay siya doon sa wind. So, kung kayang sumabay ng isang blade doon sa rotation or sa wind natin, kaya niyang makapag-generate ng more power and higher efficiencies.
Airfoil design. Thin airfoil family for medium blades. Tip region airfoil 95% radius. Primary outboard airfoil 75% radius. Root region airfoil 40% region. Thick airfoil family for large blades. Tip region airfoil 95% radius. Primary outboard airfoil 75% radius. Root region airfoil 40% radius.
Okay, so dito sa airfoil na to, meron tayong tinatawag na medium blades and large blades. So, i-observe na lang natin how different it is sa radius nila as well as dun sa paggagamitan nila. So, kailangan natin i-observe kung saan ba sila nababagay na gamitin. Next.
Blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to wind and their airfoils. Lift force is perpendicular to the airflow and is in line with blade rotation. Drag force is in line with the parent wind direction, which is in opposition of blade motion. Drag increases in proportion to the frontal area of an object facing the wind.
Okay, so itong blade aerodynamics na 'to, sinasabi lang nito kung paano yung pag-ikot ng mismong blade. So, sasabay nga siya sa wind flow para maka-rotate siya ng mas maayos. So, meron binanggit dito na lift and drag para nga makasabay doon sa may airfoils, I mean. Next. Okay, so hindi na natin ito masyadong i-discuss pero ano na lang natin 'to, i-note na lang natin itong ginagamit na lift and drag formula para sa ating mga blades.
Blade aerodynamics. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. The most curved side, or we may say the convex sides, generates low air pressure, while high pressure air pushes on the less curved side, or we may say the side with slightly concave part. This is actually the reason for the blade rotation.
So, gaya nga ng sinabi natin kanina, ito yung responsible sa pag-ikot ng ating blade. Yung airfoils na yan yung nakakatulong para mas makapag-rotate ng maayos yung mga blades natin. So, it is actually the reason for the blade rotation. Next. Okay. So, this is just the photo kung ano ba yung itsura ng isang blade natin.
Blade design. In addition to its curved design, twisted and tapered blades further enhance its aerodynamics. With the combined effect of twisting and tapering the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing drag.
Okay. So, sinasabi rin dito na twisted and tapered blades further enhance its aerodynamics. So, nakakatulong yung design niya na yan para yung pag-ikot niya, hindi siya nakakasagabal or para bang nakakasakto siya dun sa may, hindi siya basta-basta tutumba. Parang ganun. Kasi malaking part din kasi yung blade design sa pagbuo ng isang wind turbine. So, nakakapag-increase siya ng speed, ng efficiency, and nare-reduce niya yung pagdadrag. Next.
Number of blades. Here is now the question based on the previous slides. What number of blade is the best design in consideration of all factors in construction and operation of wind turbine?
So, this is just a question and siguro na-observe niyo na kung ano yung mga tamang ginagamit talaga sa wind turbine. But then, let's discuss the different design sa mga wind turbines or ilang mga blades ba yung mga ginagamit or pwedeng gamitin.
Number of blades. We already know that the rear of the blades is curved more than the front. This varied shape causes a pressure differential when the air moves across the blade, which is what causes the blades to move. Because of the obstruction of the blade, air moves at the faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. And engineers must consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag in created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag in is created, the blades could move too quickly, causing them to break the sound barrier.
Okay, so nabanggit natin kanina yung formula ng leaf and drag, di ba? Nabanggit dito na kailangan i-consider daw ng mga engineers yung pagbuo ng isang blades. So kailangan calculated ng maayos or pag-iisipan ng maayos yung pagbuo ng isang blade para na sa gayon yung efficacy or yung efficiency is ma-reach talaga in maximum level. Next.
Number of blades. The rule of thumb are the fewer blades the better, since there will be less drag and an increase in efficiency. The number of blade increases the torque and reduce the optimum rotation speed. Having fewer blades reduce drag.
Okay. So sabi dito, the fewer blades, the better. Since there will be less drag and an increase in efficiency. So, sinabi dito na having fewer blades reduces drag. So, mas magandang gagamit tayo. Ang blade kasi, kagaya sa electric fan, di ba? Wala naman tayong nakitang apat yung blades ang ginamit. Just like in wind turbines. Para mas balance yung wind turbine natin, kailangan or suggested, recommended na 3 blades lang yung gagamitin. Next.
One blade. Because of the decreased drag, one blade would be the optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced. And it's not a practical choice for the stability of the turbine.
Okay, given na to na hindi siya practical choice, hindi niya kayang i-balance, hindi niya kayang makapagbigay ng mas maayos na energy kasi nga isang blade lang yung gumagana.
Two-blade. At first glance, two-bladed turbine seems like the optimal configuration for a wind turbine, perfectly balanced, and with one blade less than a three-bladed turbine. They will generate less drag. So why aren't all turbines made with two blades? It is trouble in yawing. Yaw is when its head for or nozzle turns to face the wind due to an effect called gyroscopic precession. When a two-blade turbine yaw creates a wobble as the blades go from the vertical plane to the horizontal plane, which places additional stresses on the mounting bearings wearing them down faster.
Okay, so kung titingnan naman natin, parang ang gandang gamitin kapag two blades lang nga yung sa wind turbine. However, it is still not advisable. So sabi rito na yung nozzle, pag humarap siya dun sa wind, hindi siya makakapag-create electricity.
More than 3 blades. Any number of blades greater than 3 would create greater wind resistance, slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine.
So, if we create a wind turbine na more than 3 yung blades, so hindi siya talaga advisable and magiging less efficient yung turbine natin. Mas mapapabagal lang yan yung pag-ikot and hindi siya makakapag-generate ng proper amount of electricity. Next.
Three-blade. For these reasons, turbines designed with blades are the ideal compromise between high energy yield and greater stability and durability of the turbine itself.
So, nasagot na nito yung tanong natin kanina na ano ba yung practical or mas advisable na gagawin natin na wind turbine. So, sabi dito, ito yung 3 blades. Okay? So, ito yung mas ideal. Next.
Blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blade with the relative velocity so that its position is always at the optimum angle of attack.
Okay, so sinasabi rito na meron daw ability yung blade natin na mag-tilt or tumagilid. So, kaya niyang sumabay sa speed ng wind. So, kung hindi magkakaroon ng ganitong mechanism yung wind natin, possible na mag-against siya doon sa may wind natin. So, makakasira pa siya sa wind turbine. Next.
Nacelle. The housing of the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it.
So, itong nacelle, yun lang naman, meron siyang speed shaft, gearbox, generator, which is nasa likod no blade natin. Next.
Gearbox. Gearbox, the component which converts the slow rotation of the blade into faster speed. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a great quality voltage output. Most generators need to be turned at 15 RPM and 18 RPM. In no way, it is feasible for turbine blades to move that fast.
Okay, so yung gearbox yung may ability na makapagpa-rotate ng blade natin sa faster speed. So, binanggit dito na most generators kinakailangan daw ng at least 1,500 revolution per minute or 50 hertz para mas maging feasible siya dun sa ating mga turbines. Next.
So gearbox, a common ratio is about 90/1 with the rate of 6.7 RPM input from the rotor to 1,500 RPM output for the generator.
So, ito lang naman yung common ratio ng isang gearbox. Ito lang yung pinaka-ginagamit na ratio.
Direct drive. In a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to a gear type, the slow rotation and decreases is moving part of PMDD generator reduces fatigue and stresses on the turbine, resulting to reduced noise and vibration, longer lifetime, and lower cost of maintenance.
Direct drive, gearless. Important facts that due to wind inconsistency, the gear type turbines often operate at partial loads. The efficiency of the PMDD generators excels even in these conditions because it continues working nearly to nominal values. This design makes suited even in offshore wind applications.
Brake. The brake system in the wind turbine is a protective device coupled with sensors which automatically stop the rotation of the blades whenever it detects activities that could harm the system during operation. Very high wind speed, vital parts not working, maintenance and power lines, and etc. So, yung brake nga, automatic siya na nagpapahinto kapag may mga na-detect siya na activity na pwedeng makasira or makaharm ng system na kasi pagka na-harm yung system, mas mahirap magagawa. Mas mahirap kasing gawin yan pag nasira. Kaya dapat automatic na magi-stop na lang para hindi na mahirapan ng gawin pa.
Yaw system. Yaw system is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and other. Its function is to automatically rotate the nacelle on top of the tower so that the set of blades is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy.
Power. Wind velocity increases at a higher altitude. This means taller the tower, the greater electricity it can produce. Majority of the wind turbines are supported by conical tubular steel towers with height of usually 75 to 100 meters, depending on the blade's diameter. The tallest is still for completion in the mid of 2022, which is 280 meters, to be installed at a test center in Western Jutland, Denmark.
Okay. So these are the tower and blade diameter ratio. So may iba't ibang sizes. So every year nagkakaroon ng innovation doon sa wind turbine. So mas lumalawak or mas lumalaki yung mga wind turbines na ginagawa nila as year goes by. Next.
So the ideal location. The best places for wind farms are in coastal areas, at the tops rounded hill, open plains and gaps in mountains, places where the wind is strong and reliable. Some are offshore. To be worthwhile, there should be an average wind speed of around 25 km per hour.
Okay, so ano ba yung pinaka-ideal location ng pagtatayo ng isang wind turbine? Makikita pa rin natin doon sa pinagtayuan ng wind turbine na isa sa project ni BBM, isa nasa tabi siya nung coastal area. So para ma-reach natin yung 25 km per hour, kailangan nandun siya sa may mga places na kayang mag-produce ng ganong klaseng wind.
Advantages. Wind is free. Wind farms need no fuel, produce no waste or greenhouse gases. The land beneath can usually still be used for farming, the good method of supplying energy to remote areas. Disadvantages. The wind is unpredictable. It changes its speed throughout the day and from season to season. Suitable areas for wind farms are often near the coastal area where land is expensive. can affect television reception on nearby places.
So, syempre, meron ang advantages and disadvantages pa rin sa pagpapatayo ng isang wind turbine. So, wala siyang fuel na ginagamit, pero yung wind naman kasi is unpredictable. Nagbabago yung spin ng wind na yon in every season. So, pwede rin palang makaapekto yung pagpapatayo ng wind turbine sa reception dun sa mga places na pagtatayuan. Next.
Charges Wind Farm, Gansu Wind Farm, capacity 7,965, country China. Alta Wind Energy Center, capacity 1,540, country California, USA. Mopanda Wind Farm, capacity 1,500, country India. Hornesa Project 1, capacity 1,218, country UK. Mark Beijen Wind Farm, capacity 1,120, country Sweden. Jaisalmer Wind Park, capacity 1,064, country India.
Gansu Wind Farm. The Gansu Wind Farm project on G1 Wind Power Base is a group of large wind farms under construction in western Gansu province in China. In 2008, constructions began a 750 kVAC power line to carry electricity from the wind farm. And construction of the wind farms themselves started in August 2009. In November 2010, officials announced the completion of the project's first phase, involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts. It has an estimated cost of 120 billion Chinese yuan and $17.5 billion. The project is being built by more than 20 developers.
Okay, so itong Gansu wind farm na to, ang ginastos din is, yun lang din yung isa sa mga negative side ng pagpapatayo ng isang wind farm. Ito yung amount or yung cost ng pagpapatayo nga ng isang wind farm. So dito sinabi dito na umabot ng $17.5 billion yung gastos nila.
Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind was US $450 million, which was completed in 2015. Located within 600 hectare site, the facility consists of 50 wind turbines, each with capacity of 3 megawatt, generating electricity to Luzon grid. Each wind turbine rests on a tubular steel tower, has a 700 million hub height and 90-meter rotor diameter.
Next.
Okay, so let's discuss the hydrogen power plant.
Hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electricity energy.
So the large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. Their fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. The reactants flow into the cells, in this case, hydrogen and oxygen. So they intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out another part while the electricity is siphoned off the terminals and held in the gigantic multi-ton batteries. And the electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid, much like any other types of power plant.
Okay, so paano ba yung working principle ng hydrogen power plant? So, sinasabi dito na meron daw ginagamit na mga large tanks ng liquid hydrogen na mag-feed sa thousands din na hydrogen fuel cell. So, i-discuss natin yan on the following slides. Next.
Battery parts and functions. Electrolyte is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be liquid or paste-like substance, e.g. ammonium chloride, NH4Cl, zinc chloride, ZnCl2, potassium hydroxide, lithium tin phosphorus sulfide, L110SnP2S12, sulfuric acid, H2SO4. Anode is the negative or reducing electrode that releases electrons to the external circuit and oxidize during the electrochemical reaction, e.g. zinc, metallic lithium, lead. Cathode is the positive or oxidizing electrode that acquires electrons from the external circuit and reduced during the electrochemical reaction, e.g. manganese dioxide, carbon, lead dioxide, copper.
Okay, so meron naman tayo ditong electrolyte na binanggit, anode and yung cathode. So, ang example natin sa electrolyte is yung ammonium chloride, and then sa anode naman, so sinabi dito na yung anode daw is yung nagre-release ng electrons doon sa external circuit natin na nag-oxidize during the electrochemical reaction. While yung cathode naman is yung positive or yung oxidizing electron that acquires electronics from the external. So yung tandaan natin, yung anode is yung negative, and then yung cathode naman is yung positive. Okay, next. Okay, so ito lang yung pinaka-diagram natin ng battery. As you can see, yung anode natin and yung cathode. Yung anode nga natin is yung negative and yung cathode is yung positive. Next. So, paano ba itsura? Ano ba yung nasa loob ng battery? Makikita natin na merong metal cap, yung carbon rod, zinc case, manganese, moist paste, and yung metal bottom. So, ayan yung bumubuo sa isang battery. Next.
Battery. How it works. There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. As a result, these free electrons repel each other and try to go to a place with fewer electrons. Meanwhile, at the cathode, another chemical reactions occurs occurs simultaneously that enables that electrode to accept electrons. The only place to go is to the cathode, but the separator keeps the electrons from going straight from the anode to the cathode within the battery. When the circuit is closed, a wire connect the cathode and the anode. The electrons will be able to get to the cathode.
Okay, so paano nga ba nagwo-work yung battery? So sabi dito, meron daw couple of chemical reactions na nangyayari doon sa ating battery. And then sinasabi dito na yung electrode daw is nagre-react siya doon sa electrolyte, which is yung reaction na yun, nagpo-produce siya ng sobrang daming free electrons. Okay, next. Okay, so ito lang naman yung pinaka working principle ng isang hydrogen fuel cell. So as you can see, meron tayong anode and cathode dito. So yung hydrogen natin, yung representation niya is yung kulay red, tapos yung oxygen yung kulay blue. Tapos kung nakikita niyo yung kulay green na yan yung proton natin na positive, and then yung kulay yellow naman is yung negative na electron.
So fuel cells works like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, negative electrode or anode, and the positive electrode or the cathode, sandwiched around an electrolyte. A fuel, such as hydrogen, is fed to the anode, and air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which takes different paths to the cathode, and then the electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrons to produce water and heat.
Okay. So, yung working principle, sabi rito, yung fuels daw, yung fuel cells, hindi niya na kailangan pang i-charge. Ganon. Parang kaya niyang mag-produce ng sarili niyang electricity as long as nasusuplayan yung pinaka-fuel niya. So, sinabi rin dito na yung electrons daw is nagpo-push through siya sa isang external circuit kung saan nagke-create siya ng sarili nitong flow of electricity. So, yung protons magmamigrate dun sa electrons, which is kung saan nagpo-produce naman siya ng water and heat. Next.
Hydrogen atoms enter at the anode while oxygen is fed to the cathode. The hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positively charged protons possess true polymer electrolyte membrane, also called a proton exchange membrane. Heading to the cathode, the polymer electrolyte membrane or PEM is a specially treated materials that look something like ordinary kitchen plastic wrap. It only allows positively charged ions to pass into while it blocks the electrons. The freed electrons travel through a wire creating the electric current. After passing through the circuit and the membrane accordingly, once again, with the aid of platinum as catalyst, the electrons and protons meet of the cathode were as byproduct.
Okay, so sabi rito, yung hydrogen atoms daw is mag-e-enter siya sa anode. habang yung oxygen naman is pupunta sa cathode. Tapos, yung hydrogen atoms naman na yan is mase-separate siya into two, which is the protons and electrons. Okay, so anuhin lang natin dito kung paano ba, parang ito lang yung pinaka-summary kung ano ba yung working principle ng isang hydrogen fuel cell. Next. Okay, so ito yung pinaka-diagram niya.
Fuel cells have several benefits over conventional combustion. Based technologies currently used in many power plants and passenger vehicles. Hydrogen is very efficient fuel source, capable of producing more energy per round of fuel than gasoline. This means that an equal size tank of hydrogen fuel would give a vehicle greater range or more power than when filled with gasoline in internal combustion engine. Fuel cells have much lower emissions than combustion engine. Hydrogen fuel cells emit only water, so there are no carbon dioxide emissions and no air pollutants that create smog and cause health problems at the point of operation. Fuel cells are quiet during operation as they have fewer moving parts.
Okay, so bakit nga ba kailangan pa nating i-explore yung fuels na yan, yung hydrogen na yan? So sabi rito na mas efficient na source or fuel source daw yung hydrogen compared sa gasoline. So alam naman natin na sobrang mahal ng gasolina ngayon, di ba? So ina-explore natin kasi merong benefits na makukuha dito sa pagbuo or paggamit ng isang hydrogen. Okay.
Why it hasn't gone mainstream? Hydrogen production through methane. About 95% of the hydrogen used today is produced by a process called steam reforming, separating hydrogen atoms from carbon atoms in methane. This process is expensive and it releases greenhouse gases, which contributes to the global warming, thereby canceling out any benefits to the environment. And then hydrogen production through water naman, the other production method is electrolysis, which separates hydrogen from water. The downside is that it's expensive for hydrogen to reach its full potential as an energy source. Scientists need to figure out a way to produce it inexpensively from clean, renewable sources. And the cost of the fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approaches.
Okay, so bakit hindi nga ba siya ginagamit pa? Kasi nga, syempre, unang-una yung halaga nito, hindi siya ganon para sa masa, parang ganon. So, expensive siya masyado. And also, isa sa pinaka-important na reason dito is nakaka-apekto siya sa atin, sa mga tao, sa environment. So, may malaking factor to na maka-apekto sa ating global warming. So, hindi siya ganon ka-advisable pa rin or under pa rin siya sa research para mai-produce na siya or mai-recommend na siya sa mainstream natin. Okay, next.
Why it hasn't gone mainstream? Hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to be valuable fuel source, necessitating strong tanks and heavy-duty fueling lines, as there is currently no mainstream system of storage and distribution for hydrogen fuel. This is a major practical disadvantage. Hydrogen leaks. Hydrogen leaking can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage from wind-spread use of hydrogen fuel could gobble up ozone faster than CFCs do.
Okay, so isa rin 'to sa reason kung bakit hindi pa siya, ino-introduce kasi nga costly and then yung storage niya mahirap siyang i-store. Hindi siya gano'n kadali or hindi gano'n kadaling maka-build ng storage niya and as well as yung pagkakaroon ng leakage. Puwedeng-puwedeng mangyari yon which is makakaapekto yung leakage na yon sa ozone natin.
Latest development, long-ride energy generation project. Touted as a first of its kind power plant in the United States. The long-ride energy generation project, a 485 megawatts facility being equipped to run on a mix of natural has and carbon-free hydrogen, is nearing completion at the site of a farmer aluminum smelter on the bank of the Ohio River. The facility will burn a fuel blend that includes 5% hydrogen, 5% hydrogen in a General Electric H-class gas turbine. The plant is intended to transition to a 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electro machines that split water into its hydrogen and oxygen elements.
Okay, so eto yung siyempre, nasa process, nire-research. So eto lang naman yung mga latest development nung mga researchers natin na, by the next following decades, nag-i-increase yung renewable energy natin into power electrolysis machines na hinahati yung water into its hydrogen and oxygen elements. So eto lang yung mga latest development. Next.
The Siemens Energy. Construction begins on world's largest green hydrogen power plant, part of unique base load solar project. And Siemens Energy will operate the unique 170 million facilities is a remote part of French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts at night, and a unique baseload renewables projects that combines the world's largest hydrogen power plant with the 16 megawatts machine for electrolysis of water, and 3 megawatts fuel cell and 55 megawatts of solar panels and 220 megawatts or 38 megawatts per hour of batteries has begun construction in French Guianan Collins 2000.
So itong Siemens Energy naman is isa, yung construction niya is sinimulan ito yung project na to as one of the largest green hydrogen power plant. So ito, itong Siemens Energy na to is kayang mag-operate or kayang mag-provide ng 10 megawatts of power sa gabi and 3 megawatts, 10 megawatts of power kapag araw. And then 3 megawatts of power naman siya sa night. So ito yung difference naman nila ni Siemens Energy. Next. Okay, so that's all for today. I hope you learned something about the wind turbine and the hydrogen. Thank you for listening. Bye-bye.
Thank you.